Welcome to today's mathematics class. Today we shall be looking at the topic, the circle. And under the topic, the circle, we are going to look at the relationship between the point at the center and the variable point at the circumference of the circle, and as well as look at the radius of that circle, the relationship between these points and the radius. Here is the circle with the center O. And then the coordinates of the center are A and B. From here to this point is the radius of the circle. And this point P is a variable point, and the coordinates are S and Y. Of course, this point can be anywhere on the circumference of the circle. The relationship between the center and the variable point and the radius will still remain the same. So, given a circle, center point O with this coordinate A and B, the radius R, and P, S, Y, a variable point. 1. Equation of the circle is S minus A squared plus Y minus B squared equal to R squared. You will recall the distance formula. In the distance formula, you remember where we use S1, Y1, and then S2, Y2. In that distance formula, we now say that D is equal to S1 minus S2 all squared plus Y1 minus Y2 all squared, and then D is also squared. This was the distance formula we discussed earlier under coordinate geometry. So that same thing is what we have recalled in this case. To find the distance from the point O to point P, we apply the same rule. And that is why we have S minus A squared plus Y minus B squared equal to R squared. Now, if the center of the circle is the origin, that is the point 0, 0, and radius is R, the equation is 2 S squared plus Y squared equal to R squared. So this is the second equation, which is applicable to a situation where the origin is the center. So where the circle, the origin is the center, then we have this relationship. The third one we are going to consider is the general equation of a circle, and is of the form S squared plus Y squared plus 2GS plus 2FY plus C equal to 0. Where G, F, and C are constants. Now, let's use the completing the square method, and we are going to arrive at another formula. So, using the completing the square method, we have here S squared plus 2GS plus Y squared plus 2FY is equal to minus C. So we combine this and then combine this. Recall that in completing the square method, the coefficient of S in this place is equal to 2G. Then when you take half of the coefficient, it will give you G. So we can now write the completing the square method. We can complete this one now by writing S plus G all squared minus the square of the G plus We do the same thing to this one, where you have the coefficient of y. Coefficient of y is equal to 2f. And the half of 2f is equal to f. So we now also complete the square using this. So we now have y plus f all squared minus f squared. Everything is equal to minus c. If you expand this and simplify, you will get back the original term, which is this term. If you do the same thing to this one, you will get back this other term, which is also here. So this is completing the square method. With this one, we can write this now as s plus g all squared plus y plus f all squared. I am taking the constants to the right hand side. And this eventually will give you g squared plus f squared minus c. Now, in this situation, in this format, we now see that the center of this circle, center of the circle is equal to minus g comma minus f. Here it is positive, so it becomes negative here. Here it is positive, also made negative here. Now, next is, from here we can find the radius of the circle. Let's say the radius of the circle r will be equal to the square root. As a matter of fact, let's write it this way. R squared is equal to g squared plus f squared minus c. Remember that when we started, when you are given the center and the radius square was on the right hand side. So the whole of this one is r squared. Hence we have it. Why these ones now stand for the center of that particular circle. So you now recall from the general format, you can find the center. You can also find the radius. In this regard, our radius will be equal to the square root of g squared plus f squared minus 2. Take note of that, it's important. We are going to solve relevant questions and we'll be using this format as well. Let's take the fourth case. In this case, we are looking at the equation of a circle giving the ends of a diameter. The situation where you have a circle and the diameter, the end point of the diameters are given to you, and you are required to find the equation of that circle. There are other methods you can use, but let's specifically use this, which looks straightforward. The equation of a circle whose diameter is the join of s1 y1 and s2 y2 is s minus s1 into s minus s2 plus y minus y1 into y minus y2 equal to 0. Note that in the equation of the circle, the coefficients of s squared and y squared are always equal. If the coefficient of s squared is 1, the coefficient of y squared will also be 1. If the coefficient of s squared is 2, the coefficient of y squared will also be 2. What we are saying is that s squared plus y squared, blah blah blah, and then we have here 2s squared plus 2y squared, and then other values can be written. But notice that the coefficient of s squared, the coefficient here is 1, coefficient here is 1. The coefficient of s squared here is 2, the coefficient of y squared here is also 2. So every equation of a circle must have this format. That's why we sometimes say they are homogeneous equations. We look at examples. Number 1. Find the equation of a circle with center minus 1, 2 and radius 3. Our solution. You will recall that given the center and the radius, the equation of a circle is s minus a all squared plus y minus b all squared and equal to r squared. This is the formula for finding the equation of a circle given the center and the radius. In this regard, our a is minus 1, so we write s minus, of course, minus 1 again in bracket, and then square this, plus y. Our b is 2, so minus 2, open bracket, close it, and square that. And our radius is 3, and then also square that. Now, we will simplify this. Minus times minus here is your plus 1 squared plus y minus 2 all squared, and this is equal to 3 squared. We're taking it step by step. What I've done in this case is to make sure that simplify these values inside the bracket. So now we will expound this. Remember the expansion method. Expansion here means our s plus 1 multiplying s plus 1 plus our y minus 2 multiplying y minus 2. Everything is equal to 9. 3 squared is 9. Now remember the smiley face. Your s will multiply s, and your s will also multiply 1. And your 1 will multiply 1, and your 1 will also multiply s. This is a smiley face. Why is it a smiley face? Well, find that out. Now let's go. S will multiply s to give you s squared. The same s will multiply 1 to give you plus s. Then our 1 will multiply s to give you plus s. And our 1 will also multiply 1 to give you plus 1. Then you do the same thing here. It will now produce y squared plus y. Let's take that again. Y squared. We multiply this again. Y times minus 2 will give you minus 2y. And then minus 2 times y will give you another minus 2y. And minus 2 times minus 2 will give you plus 4. Everything is equal to 9. After the expansion, you will collect the terms as follows. Take the terms with the highest power first, s squared, followed by y squared. S plus s is 2s. Then followed by the value for y, minus 2y is minus 4y. Now let's take the constants. 1 plus 4 is 5, and then that will be equal to 9 minus 5. And so at the end we have s squared plus y squared plus 2s minus 4y is equal to 9 minus 5 is 4. Of course, we can also now write it in a more standard form, the general form, as s squared plus y squared plus 2s minus 4y minus 4. Everything is equal to 0. You see now, this is the equation of the circle giving you the center and the radius. Example number 2. Find the equation of a circle with center minus 2, 3, which passes through the point 1, 2. The solution. Let us represent the information given to us in a circle. Here is the circle, and this is the center of the circle. And the point is minus 2, 3. And it passes through another point. This is the point is also passing through 1, 2. Now we are required to find the equation of the circle. First of all, we take the center point. So we have s minus the a, and our a here is minus 2. So minus 2 minus 2 all squared plus the next one is y minus the variable point b, the point b, which is 3 here. So minus 3 all squared is equal to r squared. Now you will observe clearly here that we don't know the value of r for now, but we will have enough information that will help us to find the value of r. Before then, let's simplify this further to give us s plus 2 all squared plus y minus 3 all squared equal to r squared. Beautiful. Now let's see what happens. How do we get our arrow? Remember that your arrow will now be the distance from the center to the variable point. And using the distance formula, we now say that our arrow squared is equal to, let's get the distance, you can have 1 minus 2 all squared plus 2 minus 3 all squared. I hope you remember what we have used here is to say s1 minus s2 all squared plus y1 minus y2 all squared, the distance formula. Recall that. So when we simplify what we have here, we now have that our arrow squared will now be equal to this minus and this minus becomes plus, because minus times minus is positive. So we have 1 plus 2 all squared, and then of course we still maintain our 2 minus 3 all squared. This, by simplification, will give us 3 squared, and then this is minus 1 squared, and this will give you 9. Minus 1 squared is 1, and the value is equal to 10. So we can now write down the equation, value is equal to 10. We can now write down the equation and say that s plus 2 squared then plus y minus 3 squared is now equal to our 10, because arrow squared is equal to 10. We will now expand further and then simplify. So by expansion, this becomes s squared. Remember the expansion method which we have done earlier. So we have s squared, and that is plus 4s, and that is plus 4. Then we expand the second term, and that will be y squared, and that will give us minus 6y, and then plus 9, and everything here is equal to 10. Then of course write it in the standard form of the equation of the circle, and that becomes s squared followed by y squared followed by 4s followed by minus 6y. 4 plus 9 is 13, and so we have 13 and then minus 10 equal to 0. Finally, we can write s squared plus y squared plus 4s minus 6y, and 13 minus 10 is 3. Everything is equal to 0. And that is the equation of the circle. Example number 3. State the radius of the circle 2s squared plus 2y squared equal to a squared. Solution. Observe this equation very carefully, that you have 2s squared plus 2y squared equal to a squared. And the coefficient of s squared here is 2, and that of y squared is 2. Now, before we can find the radius, don't conclude here by saying that, oh, the right hand side is arrow squared, therefore the radius is the square root of a squared and is equal to a. No. First and foremost, you make the coefficient of s squared and y squared to be equal to 1, a unit. So what do? We divide all through by 2. So dividing all through by 2, we have 2s squared divided by 2 plus 2y squared divided by 2 will be equal to a squared divided by 2. This will now give you s squared plus y squared is equal to a squared all over 2. Therefore, our r squared is equal to a squared all over 2. Hence, your r will be the square root of a squared all over 2, and that is equal to a all over root 2. You will recall that root 2 is an irrational number, a surd, and remember that when we have a surd at the denominator, we have to necessarily rationalize the denominator. Make it rational by saying a all over root 2, multiply the numerator by root 2, multiply the denominator also by root 2. In this process, you have a root 2 in the numerator, and then root 2 times root 2 at the denominator will give you the value 2. This is the radius of that circle. Example number 4. Find the center and radius of the circle 4s squared plus 4y squared minus 12s minus 8y plus 9 equal to 0 respectively. That is to say, you first of all find the center followed by the radius. Our solution, now we write our 4s squared plus 4y squared minus 12s minus 8y plus 9 is equal to 0. Now, first and foremost, let's divide all through by the coefficient of s squared to give you s squared plus y squared minus 3s minus 2y and then plus 9 all over 4 equal to 0. Now, recall that this now can be written as s squared minus 3s plus y squared minus 2y equal to minus 9 all over 4. We are now going to apply the completing the square method to do this. And then, of course, remember this. This is the coefficient of s. So the coefficient of s is minus 3, and then half of minus 3 will be minus 3 over 2. So we write here s minus 3 all over 2 all squared, then minus the square of that value, which is minus 3 all over 2 all squared. Recall that when you expand this, you will get back this value here. So do the same thing to that of the component of y. We have here your y minus 2 is the coefficient of y. Half of minus 2 is minus 1. So we write y minus 1 all squared, then minus the minus 1 itself squared. Everything will be equal to minus 9 over 4. Completing the square method. Now, what do we do in this case? We have here now that our s minus 3 all over 2 is squared, and here we also have plus y minus 1 all over 2 all squared. We are now trying to write it to have the standard format of the equation of a circle, of the circle. So now we collect the constant straight to your right hand side. Remember that this becomes plus, we have minus 9 over 4, and this becomes plus minus 3 over 2 square will give you 9 all over 4, and then we also have here your minus 1 squared will also give you 1, and then becomes plus 1, because 1 squared minus 1 squared is 1. So with this arrangement, we will now simplify the right hand side to give us s minus 3 all over 2 all squared plus y minus 1 all over 2 all squared. Simplify the right hand side. Minus 9 over 4 plus 9 over 4 is 0 plus 1. That will be 1. So take note, what do we now have? Our center will now be equal to, here it is minus 3 over 2. Remember that it's supposed to be minus g and then minus f. And that becomes, our g is this value that you have in this place. So the value now becomes 3 all over 2. And then our f is now equal to 1. Then you talk about the radius arrow. So the radius is equal to the square root of 1. And that is equal to, remember that this one is 1, okay? So let's leave it at that. Square root of 1 is 1. I wanted to tell you that the 1 here is the same thing as 1 squared. That's what I want to say. So that when you find the square root, you will have the value 1 also. Because the square root of 1 is 1. And 1 squared is 1. So we have the radius and we have the center as illustrative. Example number 5. If the diameter of a circle joins the points -2, -1 and 3, 2, find the equation of the circle. Our solution, we have here that the equation of a circle that has the end point of a diameter is s minus s1 and s minus s2 plus y minus y1 and y minus y2, everything equal to 0. If we take our -2 minus 1 to be equal to our s1 y1, we will also now take our 3, 2 to be our s2 y2. Now, replacing each of these in the equation, we now have s minus our s1, which is -2, so there's a -2 there. Open the bracket and close it again. Open another bracket. We have our s minus s2. Our s2 is 3. So we write that, close that, plus your y. And our y in this place, our y1 minus y1. Your y1 is -1, so we have -1 again. Close that. Open the bracket. You have y minus y2. Our y2 here is 2, so -2. Everything is equal to 0. Let's simplify this. First of all, simplify inside the bracket. So we have s plus 2, and then we have s minus 3. We have y plus 1. We have y minus 2. Everything is equal to 0. Now with that, we will expand or open the bracket, smiling face, or whichever method you would like to use. S squared minus 3s plus 2s minus 6. Then we have y squared minus 2y plus y minus 2, everything equal to 0. Alright. We now write this in the standard form. First of all, let's simplify. We have s squared minus 3s plus 2s will give you minus s. We have minus 6. We have plus y squared. We have minus 2y plus y will give you minus y. We have minus 2, and that is 0. So, in the standard form, we have s squared plus y squared minus s minus y. Minus 6 minus 2 is minus 8. Everything equal to 0. And that gives you the equation of the circle that have those joints, the endpoint of the diameter of the circle.